A 143-gram baseball going 39 meters per second is caught by the catcher. In stopping, the baseball travels 7.5 centimeters. What is the average force exerted on the ball? Okay, let's draw a picture of this. Baseball. Traveling, right? And it hits the catcher's mitt. I'm sure it doesn't even travel that far. But let's imagine that it slows itself down in 0.075 meters. So the centimeters, right, I just have to divide by 100, right? I just sort of move the decimal place over 2 places, right? Okay. Okay. What is the force? Okay, so we notice we have the mass. Our mass is 143 grams divided by 1,000, right? So it's 0.143. That's the weird zero. Okay, kilograms. We have the mass, but we don't have the force. It's asking for the force. So we have to solve kinematics first, then we'll do F equals ma, right? So F equals ma is the last thing we'll do. The first thing we'll do is this, x, vi, vf, a, and t. Okay, so let's see. I guess it moves forward 0.075 meters, right? Okay, so this is the positive direction, this will be the negative direction. The initial velocity is 39 meters per second, that's pretty fast. That's almost 90 miles per hour. Final velocity is 0, because it stops. And then I guess we want acceleration, and we want to use no t, right? Because we don't really care about the time. It doesn't ask for that. So no t is this guy. Okay. Final velocity is 0, so 0 squared is 39 squared plus 2 times a times 0.075. I think I finally got the distance right. Okay. So now I've got the opposite of 39 squared, right? Equals 2 times a times 0.075. So what I'm going to do with my calculator is I go the opposite of parentheses 39 squared, right parenthesis. And now I've got a big number. It's negative 1521, right? That equals 2 times a times 0.075. All right, so my next thing to do is I'm going to divide by 2. And I'm going to divide by 0.075. Oh, that's a big acceleration. Wow. Okay. This is reasonable. I mean, this is, I would think a baseball mitt isn't going to move back 7.5 centimeters. It's kind of why, I think this is why baseballs hurt, you know. Okay, so this acceleration is big. It's negative 10,140 meters per second squared. That's crazy. That's like 101 Gs. Okay, so now we're set. Okay, so our force is equal to mass, which is 0.143. That's this guy, right? Times negative 10,140 meters per second. I knew there was a reason why baseballs hurt. They're going fast. Wow, look at that. Okay, it slows down considerably faster when it hits you in the head, too. Let me just tell you. Okay, times 0.143. And I get the force is equal to negative 1450.02 newtons. All right.